In this video, we continue with Chapter 4 on linear modules and matrix algebra, specifically focusing on vector operations. Remember from video 4.1 that a vector is a special case of matrix, in the case that it can either be a row vector or column vector. A row vector's dimension is 1 times n. A column vector is m by 1. Now, if we have, for example, vector u equal to 1 and 2, what is this? This is 2 rows by 1 column. So u is a column vector. If we have vector v equal to 6 and 2, this is a 1 row by 2 columns, which means v is a row vector. Vector multiplication is a special case because it can lead to one of two things. It can either lead to an m by n matrix, or it will lead to a scalar. So for example, if we take u and v, u is 2 by 1 and v is 1 by 2. So we need to check conformability. So yes, we can multiply u times v. What will we end up with? We'll end up with a 2 by 2 matrix. So u times v will be equal to 1, 2 times 6 and 2. So what do we get? Row 1, column 1 is 1 times 6. Row 1, column 2 is 1 times 2 is 2. Row 2, column 1 is 2 times 6 is 12. Row 2, column 2 is 2 times 2, which is 4. So we end up with a 2 by 2 matrix. If we have VU, V is 1 by 2, U is 2 by 1, so check conformability. Yes, V's column is equal to U's row. What will we end up with? A 1 by 1 matrix. So V times U will be equal to 6 and 2 times 1 and 2. So row 1, column 1 will be equal to 6 times 1 plus 2 times 2. 6 times 1 is 6 plus 2 times 2 is 4. So 10, so what do we end up with? A 1 by 1 matrix, which is a scalar. Another important aspect of vectors is their geographic representation or interpretations. So if we have vector x, which is equal to x1, x2, it indicates a movement on the Cartesian plane. So for example, if we have u equal to 1 and 2 and v equal to 5 and 1, this will be x1, x2 on a plane of x1 and x2. If we take u, x1 is equal to 1 and x2 is equal to 2, that would be that point. So the vector u, indicated with an arrow, is u1, 2. If we take v, x1 is 5 and x2 is 1. So it would be that point. From the origin to that point, we have vector v. What we sometimes do is we indicate that it's a vector with an arrow above it. So 5 and 1. So let's just indicate u as a vector as well. So you can find more examples of vectors and the Cartesian planes on page 61, figure 4.2. What's also useful is we can add more dimensions with vectors. So for example, u equal to x1, x2, x3. In this case, it's a three-dimensional movement. And you can see an example of this on page 64, figure 4.3. So for example, a 3x1 scalar would be a three-dimensional scalar. If we add more elements, so x equal to 4, it would mean that there is possibly a spatial dimension to the vector as well. What's important to remember, vectors are special cases of matrix, either a column or a row vector. Their movement in the Cartesian plane and their multiplication will either give you a matrix with an m by n dimension or it will give you a scalar.